Morning, everyone. Hello, thank you very much for getting up early to come and listen to me. Appreciate it. I know what the mornings of day 2 can be like, so appreciate you all managing to leave the hotel and come and listen. So my name's Jack. As Alex said, I'd like to thank Alex and the whole team for inviting me over here. It's been an amazing trip so far. Doing the workshop on Wednesday was great. Really enjoyed the talks yesterday, and it's a pleasure to be up here today talking to you. So I want to talk to you today about components on the web. And really, this talk is 50% about components and 50% me trying to shoe in lots of references to Lego. Lego really was my favorite toy growing up. Hopefully it was some of yours as well. And there's a lot of things about Lego that actually map very nicely to components on the web, which is why I want to talk about it today. I think the term component has become very overloaded in the front-end space. Depending on which framework you use, which blog post you read, which talks you listen to, the term component can mean a lot of different things to a lot of different people. So just before I kind of dive in, I just want to talk a bit about when I say component, what I actually mean by that. I've stolen this great slide by a guy called Cristiano Rastelli, who talks a lot about this stuff, and I really recommend giving him a follow on Twitter and reading his blog. But here, when I talk about a component, we're talking about a kind of related bit of HTML, CSS, and maybe JavaScript that makes up one part of a user interface. It might be a bigger part, like a form, but that will probably be made up of smaller parts, like a submit button, an input field, and all the rest of it. So that's what I'm talking about today when I talk about components. I'm also not going to talk about components in a very framework-specific way. A few of my examples will use React. That's personally what I am most familiar with. But this talk is at a level where if you use Vue, Angular, Ember, React, any of the frameworks, or just plain web components, Polymer, those kind of things, hopefully you'll be able to take away a lot of ideas from it too. So I want to talk today about the road to components, kind of the learnings in the front-end space that got us here, the theory of them, how they work, and then go into a bit more practical of my experiences building components, kind of gotchas that I've been caught by, and how to avoid them in the future. I also want to then talk about how if you've got a bigger project, you can actually introduce these components into your system without having to rewrite everything from scratch. And as I said, this talk is really about my experiences over the last couple of years kind of working in this manner. As Kit said yesterday, I would by no means consider myself an expert in this space. I've just been using it and want to tell you what I've been up to. I'm sure a lot of people have been working with components in whatever framework or kind of fashion you prefer. And I'd love to come and hear your kind of experiences of it. So please feel free to come and grab me or tweet me. I'd love to kind of hear more. So when we first started pushing logic from the server onto the client, we stuck with what we knew best. And that was we left everything on the server. So the models, views, and controllers, all that stuff was on the server. We put a big wall up between them, and then we used jQuery to build catpics.com, and that was roughly where we were at. And then over time, we started building more ambitious user interfaces, more ambitious, complicated web apps. And before kind of React and Angular and all those frameworks came along, we really were just writing jQuery, or there was this whole you don't even need jQuery.com phase, the vanilla JS kind of phase. But really, whatever way this worked, we ended up with a big kind of mess of code. And this kind of approach didn't really scale as we were trying to build these complex apps. We then had this tremendous period of kind of tooling and investment and exploration where thousands and thousands of libraries were released onto the web every single day. This became known as JS fatigue online, and it was kind of a quite popular blog post title and hashtag. But really, for me, I think this was really exciting that we had this problem, that old solutions weren't working, and so we kind of threw loads of effort and loads of people at figuring out better solutions. So actually, as a front-end developer, it was quite exciting to kind of go through this time where every week there was a new thing, and it was very interesting to see kind of what would come out on top and how ideas would fuse together. What's really nice about this is, from this phase, we end up with things like Angular and React and Ember and all those frameworks. And what's nice is that they all took different bits from each other to kind of advance forward. They all saw what was working and what wasn't and kind of moved on together. I think it's really nice, and we're very fortunate in the front-end space that we don't have one framework that exists that we all use. We have lots, and they inspire and kind of work against each other to improve themselves. But this MVC kind of approach that we'd use on the server, if any of you are like Ruby on Rails developers, you'll be very familiar with this model view controller. It doesn't really fit front-end development, but we tried. So the first kind of front-end frameworks were MVC. That didn't quite work, so we went for MVVC, model view controller, I think that was. Then there was even like MMVC, I don't even know what that means. And then I'm pretty sure I saw one framework that was MVV, CC, VV, MMMMM, CC, VV. I practiced that a lot last night, that particular line. The rest of the talk's a nightmare, but that line I nailed. And it turns out we already had the answer we were looking for. And really, the way I like to think about this is by thinking about one of the best films released in the last couple of years, a real contemporary classic. How it didn't win Oscars, I don't know. But it's really a great film that's full of lots of bits that these people put together to build spaceships and the Batmobile, and they attack the Joker, and he rides out on balloons, and it's all made of Lego, and it's a great movie. Highly recommend watching it. But it turns out when we work on the web, we already have this big box full of Lego components that we can work with. And it's called HTML, if my clicker will go. We tend to call these elements. We have paragraph elements, heading elements, unordered lists that have list item elements inside. But if you just kind of squint a little bit, you could really call these components. An HTML paragraph, you dump it into the page, it comes with some semantics, like it defines that content as being a paragraph. But also, by default, the browser will style it slightly differently to how it will style a heading. So these really are reusable chunks that we can put into the page. And then we saw the web component spec that said, well, what if we could have our own bricks that we can extend into this big box and make an even bigger box? And then people started thinking, what if we build frameworks around this idea rather than the MVC approach? What if we go down the components road? And so the rough kind of theory behind this is, let's take a website that we've probably all used once upon a time, every now and then, a Twitter. I should make it clear, I have never worked for Twitter. I'm pretty sure they don't follow this exact layout in their code. But I just wanted to pick a website that we're all familiar with. The idea here is we have a bunch of components that are all responsible for putting different bits of the user interface into place. Some of them are quite big, like the feed, which renders all my notifications. But all that will be made up of is lots of smaller components that render one tweet. And so you can kind of start thinking about a page as a big tree of components. So pages are a series of these components. Pages will reuse common components. The tweet component on Twitter will be used in a bunch of different places. As it turns out, this approach works pretty well. It's the approach I've been working with now for 2-3 years. It seems to be the kind of direction the front-end community is headed in quite strongly. And for me, I first kind of came into this via React. I found React when it was relatively early on and really enjoyed the component approach that React took. I'm not saying React introduced all these ideas. There were lots of these ideas floating around. But I think React kind of popularized quite a few of them. And what's interesting is a lot of frameworks have been inspired by React, and vice versa. React has certainly taken ideas from others too. And so I'm going to use React today in a few code examples, because it's kind of my framework of choice at the moment. But this talk isn't framework specific, as I said. And whether you're talking Angular, Ember, Vue, web components, anything else, hopefully this will still be useful for you. But as the people who came on Wednesday know, you should already be using Elm. So approaches and challenges of building good components. I want to actually dive into, if you're building these kind of day by day at work, what are the kind of mistakes or pitfalls you could fall into that will cause you harm in a few months or make code harder to work with? And you've got to remember that primarily components are designed to be a black box. And this is really the #1 thing to bear in mind when building them. If I want, let's say I'm traveling back 10 years and I want a carousel on my website. And I know that in our previous website, I built Jack's custom fancy carousel, which is very exciting. And I can give it the speed and if it should play infinitely or not. And now if you're a user who wants this cool carousel on your website, which you probably do, because it's pretty fancy, as you can tell by the name, you can just dump this into the page. You don't have to worry about the specifics of how it works. You don't have to worry about any of the stuff that's going on under the hood. It's all hidden behind this fancy carousel. And this black box approach is the really powerful one. If you remember one part of this whole talk, it should be that the components are like a black box. Because what it enables is working really well in isolation. So I work, as I said, for a company called Thread. We're a men's online fashion website. And you can go on Thread, and you can click on shirts, and you can see lots of shirts. And let's say the user's on this page one day, and we get a bug report. Now, you can't see it on there, but when you hover over any of these items, you can click a little heart that appears to tell us that you like the item. And we have a whole machine learning setup that will learn from that and recommend you better clothes in the future. And let's say the user's found a bug. The heart icon isn't working. Now, because this is a website built up mostly of components, I can forget about the whole big picture and just zoom into the bit where the bug is. And for me, that's this component. As a whole, I call this the item card. But the item card is made up of even smaller components. There's the image, there's the details, there's the preferred size information. And crucially, there's what we call sentiment, which is if you like or dislike the item. And so the user's told me there's a bug in clicking the heart icon. I can now forget about the whole rest of the website, all the code we've got, and I can zoom right into that item sentiment component, which is where the problem will be. This is really beneficial as a developer in terms of speed. You can zoom right in on the problem area and don't worry about the rest of your website and what's going on. If you've built these components as a black box, you can also know that you won't ever kind of break something in another part of the site by working on the sentiment component. And we take this one step further. We literally put all the files in one folder. So per component, everything that ever relates to that component is in the same folder. So literally, you can load up one folder in your editor and ignore everything else. And it makes for a really nice, productive working environment. I think we can spend a lot of time thinking about kind of fancy file structures and how we're going to structure our project. If you haven't tried having a folder per component and just dumping stuff in there, I'd recommend giving it a go. The next thing to bear in mind when building complicated components is that you should try and avoid all business logic. Components are primarily presentational, and they focus mostly on presentation and user interactions. So if you've got a big chunk of code for doing some logic, here, for example, I've got a sign-up email form, and I've got lots of code in the sign user up function that kind of makes a request to our server and does all sorts of boring stuff. That stuff doesn't need to be within this component. By putting it in this component, you make it harder to test, and you just make it harder to work on. The more code there is in a file, normally it means the harder it is to work on, just because there's more stuff for you to deal with. And so by letting the component focus just on the presentation aspect and pulling all the complicated kind of logic out into standalone functions, you clean up your components, you make them easier to test, and you can also now test this signing a user up logic in isolation without having to worry about the component. So try and keep your components very, very clean. The main challenge you'll come across when writing these components is the challenge of reusability. It's a fact of life that reusable components have to be configurable. In the grand ideal world that unfortunately none of us live in, you could build one component and use it lots of times on your website and it will just work. That does sometimes come true for some components, but for others, you want them to look nearly the same or behave slightly differently. And so you need to be able to configure these components in some way. So let's say you work a thread and you get, someone says, hey, we need to build a component to view an item of clothing, like the item card that we saw earlier. So you load up your editor, you write some React, you do the CSS, it's all there. And then you provide this thread item component. So you can dump it in, you can pass it in the item that it should render, and that's job done. This is the really nice thing about components. Now, as a user, I can use this thread item component. I don't have to worry about how you built it. If I'm another developer on your team, I can use your work, and it's great, and I love it. And then if someone says, oh, we don't want to show just one, we want to show a big list. OK, I'll just dump these in loads of times. And when you've done this for a few times with a component you've built, you'll see the real power of these components. Going from like showing one to showing a list of them is effortless because you just dump them in. And you know, because they're all these kind of black box approach, you know that nothing is ever going to get in the way of that. And then someone says, well, on some pages, we want to show the brand alongside the item. So we add another kind of property. In React, these are called properties. If this was HTML, these would be attributes. So you can kind of think of them as the same thing. And then someone says, oh, and if it's on sale, we want to show the old price alongside the new price. So we add yet another property. This is good. We're making our component configurable. So depending on what page we're on, we can do different things. But it's still kind of a black box that we can just configure a couple of items on it. And then someone says, well, sometimes we don't want to actually show the sentiment. We don't want to let users like or dislike items in certain situations. So you add another property, and you begin to think, well, this is getting a bit confusing now. If you're a developer in a few months' time, you come back to this, there's quite a lot of options to remember. And then you add yet another one. For some items, we show the brand instead of the name for whatever reason. And suddenly, you've gone from this component that was really reusable, you just gave it an item and it rendered the item onto the page, to one that now takes a kind of plethora of options that are very difficult to remember them all. At the time, you'll probably be thinking, this is great, I can remember all these, it's easy. But if you come back to this in 6 months' time, it'll be very easy to forget that you can do some of this. And this is a trade-off you're constantly going to be making if you're building components and you're building big websites. You're constantly going to play configurability off against maintainability. Every prop or kind of attribute that you add lets the component be more configurable, but it also means there's more code and more work for you as a developer to understand that. So this great tweet the other day says, any code of your own you haven't looked at for 6 or more months might as well have been written by someone else. And I know that I certainly find that true for code. I mean, I hate 6 months ago Jack. He writes really sloppy code. Present Jack writes great code, but past 6 months Jack writes, it's dreadful. Honestly, it's embarrassing. Maybe that is just me, but yeah. All right, let's quickly move on. I hope my boss isn't watching. Okay, so I want to briefly touch upon CSS. So we talked about these components being boxes of functionality, and that includes CSS. Every component should provide its styling. You think of these as a box with HTML, CSS, and JavaScript in, and none of them should conflict with each other. So if I've got a big page full of loads of them, they're all in their boxes. None of the CSS should get in the way of any of the other CSS. And really, I could do a whole talk on just CSS and components. I'm going to kind of whiz through it briefly, but come and grab me, do some Googling. There's lots of useful resources out there. So there's 3 approaches I want to talk about. This is a big topic, as I said. There's lots of good talks on YouTube that go into this in a lot more detail, so I'd recommend giving one of those a watch. The first kind of approach is the easy one. You say, well, we're just going to use normal CSS, but we're going to be really strict about it, and every component will have a class name that we use. And then no other component can ever use that class name. And yeah, that will help. That will be fine. But then one day, I'm in a rush as a developer. We've got a deadline. We need to ship something in the next hour. And I realized that the thing I'm building has a lot of CSS that's shared with Jack's carousel. So I think, you know what I'll do? I'm a sneaky developer, and I'm lazy as well. I really hope my boss isn't going to watch this talk. I'm just going to use the Jack's carousel class on this other component I'm building, because they look like nearly the same. They're pretty much identical. And you probably do this with the best of intentions. You say, I'll do this for now so we can ship, and then next week I'll tidy it up and I'll fix all my mistakes. I don't know about you, but I never get the time to fix all my mistakes. I should probably stop admitting all this stuff live on stage and on a talk that's going to be on YouTube. But basically, past Jack writes dreadful code. I never fix any of my mistakes, and I'm lazy. And those are the key takeaways. But you'll do this. You'll do this little kind of hack to get something working, but you'll run out of time to fix it later. And so really, just sticking to CSS classes isn't a good way of doing things. The way we've chosen at Thread is to use something called CSS modules. The way CSS modules work is we define our CSS as normal, but then we use a build tool like a Webpack or one of the many others out there. And what this does is at build time, it swaps out the class name like Jack's carousel for a unique class name with kind of a random hash on the end of it. What that means is your class names are guaranteed to be unique, so you can never accidentally reuse them from another component. So if you look at build time, you can see the classes on that unordered list and list item have been turned into like shipping type, toggle module, blah, 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 with a random hex on the end. So I can't, as a developer, like reuse this class somewhere else because it's just not going to work. The final approach is to use CSS in JavaScript. Again, this is a huge topic that I wouldn't try and cover in like the minute I have here to do it now. There's lots of solutions. I'm most familiar with one called style components, so that's the one I've used for this example. But I would recommend having a Google. There's lots of resources to all the different approaches you can take in this space. CSS in JavaScript just says, well, why don't we just put the CSS next to our components? Because really, that's where it belongs. So we write CSS in whatever form, and we just use these components in our page. And so now you've done away with CSS. So you can never have any global class names getting in the way of each other because they just don't exist. Some people kind of heavily disagree with this approach and think we should keep CSS in CSS. Some people absolutely love it, and I think I sit somewhere in the middle. So really, this depends, as kind of you and your team should decide what you're most comfortable with. If you would like to dive into style components, I did a video with Glenn Madden, who's one of the creators of style components. It's up on the blog. It's entirely kind of public and free and all the rest of it. I'll share a link to these slides afterwards with the hashtag so you can find it as well. As I said, it's really up to your team to decide what your favorite approach is in this space. There's loads of different solutions. I wouldn't recommend picking them just from these 5 minutes of slides. I'd really kind of dive in online. Another challenge is when should you break a component down? We aim for quite small components generally. Typically, for components to be usable, they should be quite small. If you think back to Twitter, if I made a big notifications component that just rendered all my notifications, I can't reuse that anywhere else on the site. But because if I make a feed component and a tweet component, those can be reused across the site. But it's challenging knowing when a component is getting so big that really it should be like more than one component. Components are cheap. You should have lots of them. You will end up having lots, and some of them will be very small. But they're not free. Every time you introduce another component to your system, you do pay a bit of cost. You pay in maintenance. More components just means more code, and that means more work to keep it all running smoothly. You pay in complexity. There's another component that exists that you have to remember about and know how it relates to everything else. And you pay in communication. If you're putting another component into the page, it's probably going to have to get some data from somewhere. So you're going to have one component pass some data around to another component. So components should be small, and you should have lots. And really, a big box of like various Lego pieces is the perfect kind of way to think about this. But you should be wary of just having loads and loads. Like a Lego box with just 1x1 pieces in is not much use to anyone. But one with lots of 1x1s and 2x2s and 2x4s, that's more useful as I'm building my big, cool battleship. So how do you know when a component is getting too big? The first metric I recommend is one that I never recommend for anything else. But it's how many lines of code is it? This seems silly. Like, this usually isn't a good way to judge any of your work. But for components, it kind of makes sense. You just think, well, a component's got 500 lines of CSS and JavaScript. That's just quite a lot. And there's no kind of fancy science here around how many lines is perfect. But if you've got loads and loads of lines and they're very overwhelming, you should, that's probably a sign that you could do some work here. Another one is how many different HTML elements does it produce? Do you have your component just outputting a heading or just a list of things? Or does it output a heading, a list, a div, some other stuff? Again, that's probably a sign you could split it up. And this is very subjective, but how hard is the file to understand? The whole benefit of these components is they're black box, you work in isolation, and therefore if you load up a component, you should be able to understand it pretty easily. And it shouldn't take you too much time. If it does take you lots of time, that's probably a sign that there's too much going on in there. And another one, which sounds silly, but this is one that I fall for all the time, is does your component's name have and in it? Now, you'd think this is incredibly obvious. And yeah, and again, past Jack is a complete idiot, as we've learned. But I wrote a component once called item name and price. And that seemed absolutely fine to me. And then later on, a colleague said, shouldn't that just be item name and item price separately? It's like, oh yeah, probably should. We've already touched upon this, but another challenge we found is you have to allow components to vary slightly in their UI as well. In an ideal world, again, this wouldn't happen, but in reality, it often does. So on Thread, you can like and dislike items. We call this sentiment. And there's a few different ways you can do it. You can see on the left, we've got kind of 2 buttons. On the right, you might just be able to make out there's a little heart and cross just below the picture of that rather interesting blazer. And on the right, we've got these bigger buttons too. These components are 95% the same. All the logic is the same. They make the same API calls, all the rest of it. But they just look subtly different. And there are times where you can sit down with your design team and say, well, actually, can we just make these look the same? And it will save a lot of complexity. But there are other times where you will need to be able to do this. So the way we've taken it is we explicitly allow what we call component variants. So we list the variants that a certain component can have, and you can pass that in when you render one of these components. They have a default, but you can pass in an override if you want to. We found by explicitly listing the variants that you're allowed and then applying CSS accordingly, that's a nice way to kind of deal with keeping the components the same, keeping them configurable, but allowing slight visual differences. The key here is to allow just very slight, small visual differences. If you've got a component that can be rendered completely differently, that's probably 2 different components. And really, a more general rule that works for components but works everywhere else as well is favor explicit code over implicit knowledge. Don't have some like hidden CSS that will change the behavior of how something looks. Pass in an explicit like variant property or flag or attribute. And you should be you should be aware of breaking the abstraction when building these components too. So we've spoken about this black box abstraction, like your code is in a box and nothing can reach into it and mess with it. But sometimes you might have to break this abstraction. A good way to know if you've built a component that is black boxy is to say, okay, could I pick up this component out of my project, create a brand new project with nothing else in it, and dump my component in, and would it work? If so, the component is a complete black box. There's nothing it needs to be able to work correctly. But in real life, you can't have all your components like this. Components need to get data from somewhere. Some of them will rely on other libraries that you need. Like if you're building a React app, you might have Redux in there, and some components will need some data from there. And so you can't have every component be a complete black box. Unfortunately, it just doesn't quite work. The trick is to think very carefully about how you structure your components so that it's very clear when components do take data and when they are just more like black boxes. It's better to have fewer components taking in data and most of them be this kind of black box. Just to briefly touch on the kind of approaches to giving components data. So if you've got a front end, you might have an API with data. You need to get that into your components. There's 3 approaches. You can use APIs. Components can make HTTP requests. The components can be given data from the server, and they can pass data left in script tags. These are the 3 approaches we've been using. So in the APIs, your component might render a loading spinner, fetch some API, and then deal with fetching the data and showing an error if something went wrong. Sometimes we just use templated data from the server. So if you view the thread.com source code, you'll see stuff that looks like this. It looks like a bit of a mess, but this is server generated. Like, thankfully, we don't have to write this by hand. But you can see we've got the thread item card component. It takes an item prop, which is a big dump of JSON. And you'll see this throughout the site. If we look at this product sentiment example, you see we pass in all the data we need from the server. The final approach we use is having data in script tags. So we dump some kind of quite global data, for example, is the user logged in or not, into a script tag on our page. We write a little utility that lets us know and read data from there. And then we can use that in a component. So a component can easily check if a user is logged in. These approaches have pros and cons. APIs are good for more complex data that's changing all the time. But the issue with that is then if you render a component and it then needs to fetch data, that's slower before you get the data in front of the user. And there's kind of pros and cons to each one. You should think carefully about what works best for you. So my final few minutes, I just want to talk about the path to components today. What happens if you're at work and you like this approach and you want to start introducing it to your existing app? And Thread is actually a really good example of this. Thread is 5 or so years old. It's a server-side rendered Django application. Django is like Ruby on Rails-ish, but for Python. And it renders HTML via server-side templates, much like many websites do. The JavaScript historically was just layered on top via some jQuery or plain JavaScript or whatever. And although we had this kind of big architecture in place, we were still able to start introducing components. We now have roughly 50 or so, I think, give or take, and that number is going up all the time. So even though we're not building a complete brand new single-page React app from scratch, we're still able to use a lot of these approaches and introduce it to an older code base. This is like the perfect image that I found for this talk online. But you've got this big wall of stuff, and you can just start putting in Lego bricks. This is, I mean, I would never go inside that building because I wouldn't trust it, but I like the picture. A nice kind of technique for doing this that we found is to wrap your framework components in actual web elements. So this is the only React-specific link. It's to a project called Reactive Elements, but there are similar things exist for all the other frameworks, or you could write one yourself pretty easily. What this lets us do is in our JavaScript, we import our React, and we call this thing called register React, which is provided by that Reactive Elements library. And that creates a web component that will just mount our React component within it. So then in our server, we can use these templates like thread-item card, and that will render the React component that we've given it. This lets us introduce React in our component system without having to rewrite a lot of functionality that we already have on the server. Lots of our stuff is server-side rendered, and that makes perfect sense for what we're doing, but we can inject little bits of React in where we need to. And then on pages where sometimes, it's hard to believe, but sometimes we don't need JavaScript, it's weird, we can still just use our server and render HTML and CSS. And when you're working on a big app like this, you've probably got some areas of the code base or some parts that are quite hard for you to work with. They're what you might describe as legacy code. It's code that's hard to touch, hard to work with, and it's just a pain all around. Components let you actually do this really well. And a good example is we rebuilt some of our checkout recently, and we moved it to React. And I don't know if it's outside the UK, I'm not sure. In the UK, we have a service called Collect Plus, which basically lets you, will ship your parcel of clothes, not to your house, but to a store near you that you can then go and pick up. So if you're not in during the day, you can still go and get your stuff from a store nearby. And the Collect Plus has this horrible widget API thing that you have to hack together to get it to work on your site. And it was a pain. But when it came to rebuild and checkout in React, I didn't really want to have to dive into this Collect Plus API widget stuff and make sense of it. I just wanted to kind of leave it alone. But you can take advantage of the black box abstraction, and I made a React component called React Collect Plus, and inside there I just dumped all the horrible legacy stuff. And down the bottom, in our templates, we can still use thread-collect plus, but now all this horrible legacy code is boxed away in its own little box. So you can use the black box abstraction to hide away bad code in a layer of good code. And sure, it's not ideal. We'd rather the Collect Plus widget be much better written, and we could work with it. But for now, when we don't have time to rebuild it all, and we don't need to, it works perfectly fine. We've just sort of hidden that bad code away for a bit. We sort of swept it under the rug. You shouldn't do this all the time, else your code base can become hard to work with. But when you don't have time to rebuild something, it's a pretty good approach. The black boxiness of components is also really good for letting you try new technology. So for example, we were writing loads of components in React, and we hadn't decided on how we were going to do CSS yet. And so we decided, well, for the next component, let's make it use CSS modules. And we'll have another component that we build that will use styled components, or one of the CSS and JavaScript type solutions. And so we did that, and we deployed both of them. And then we built a couple more, and we talked about it, and we decided that for us, we preferred CSS modules over styled components. We liked the fact that we could still write actual CSS rather than it being JavaScript. Again, that's our choice. You might decide differently, and that's absolutely fine. And of course, over kind of the long run, all your components that you're deploying should use the same set of technologies. If you work on a site, it's got some in React, some in Angular, some in Vue, some in Ember, that's going to be very hard to work with very quickly. You're also going to have to ship all of those frameworks to the user, which is non-ideal for performance. But doing it temporarily so you can kind of compare two technologies is pretty valuable. It's easy to get distracted, like in the office with your colleagues, talking about, should we use CSS modules? Should we use style components? Should we use this? Should we use that? But actually, components that you just do it, wrap it in a box, ship it, and see what you think. So to sum up, keep your components small and be wary of too much configuration. Beware anything that breaks this black box abstraction, but accept you will have to do it sometimes. Prefer explicit code over implicit knowledge of how your components interact. Make all that very explicit. And remember that we're all figuring this out together as we go. So if you do have any thoughts, I'd love to hear them. Just to finish with a shameless plug, wouldn't be a talk if I didn't do a shameless plug. As Alex said, I do some video series on javascriptplayground.com. I have one on testing React using Enzyme and Jest. The first 5 videos are entirely free online. You can watch them on YouTube. They won't cost you a penny. If you want to buy the rest, it's normally $20, but if you use the code JSHeroes, you'll get 50% off. If you have any questions about that or anything else, feel free to come and grab me. I'm Jack_Franklin on Twitter. The slides are up on Speaker Deck, and thank you very much for listening.